side 1. So here we have considered two sections. One is this number 1, and here this is number 2. Number 1 is in higher elevation, and number 2, section number 2 is in lower elevation. So that's why the water is flowing from 1 to 2. Okay, here RL is higher than RL of 2. Okay, so that's how water is flowing. So what we do in first section, we measure depth of flow and we consider as Y1. Okay, in first section we measure depth of flow and we consider Y1, and then we measure the velocity. Okay, and we consider as V1 for first. Similarly, for second section also we measure the depth of flow and we consider Y2, and we measure the velocity for the second section and consider its V2. Am I clear?
Sure.
Okay. Okay. Thank you. Okay. So now we need to find out the total energy for first section. Okay. So now I want to say you what is total energy. So total energy is nothing but when you add kinetic energy head. Okay. Kinetic energy head, not kinetic energy. It's kinetic energy head. Okay. Next one is potential head, or you can say potential energy head, and the third one is datum head. If you add all the three, you are going to get total energy. Not total energy line, you got total energy. Okay, if any section, if you add kinetic energy head, potential energy head, and datum head, then you are going to get total energy for that particular section. Okay, so now see, and similarly, if you want to find out the total energy, for section 2, you have to add all the three. That is your kinetic energy head, then potential energy, and then your datum head. See, when we calculate total energy, we have to calculate with reference to a line. Okay? That line is called your datum line. Okay? We have to calculate this energy, total energy, with respect to a reference line. And that reference line should be same for both section A and section B, or you can say section 1 or section 2. Okay? So we have to consider one reference line, that is called datum line, and that line should be same for section 1 and section 2. So now if anyone asks you to what is datum line is nothing but it's an imaginary line beneath the ground. Okay, you can put here or you can here, but this reference line should be same for both the section 1 and section 2. Okay, so this is your total energy. Once you calculate the total energy for first section and you calculate the energy for second section and you join both the point by a straight line, that is called total energy line. Okay, that is called total energy line. If you join the total energy of section 1 and section 2 by a straight line, that line is called total energy line. Okay, clear? Okay, so and then in the first class I asked you one thing, what is specific energy? specific energy, or how it differs, or the specific energy is nothing but if you calculate the energy with respect to the bottom of the channel. Okay, that energy is called specific energy. That means in specific energy, just a minute, okay? The students are waiting. Okay, now it's okay. Okay. In specific energy, we have only kinetic energy head. We have only kinetic energy head. We have kinetic energy head and potential energy head. Okay. If we add these two, we will get specific energy. That means if we calculate energy with respect to the bottom of the channel, or you can say bed of the channel, then that energy is called specific energy. If we calculate energy with respect to the reference line or the datum line, that energy is called total energy. Okay. So in specific energy, we have only two, that is your kinetic energy head and potential energy head. In total energy, we have kinetic energy head, potential energy head, and datum head. All the units, that is your kinetic energy head, that unit is in meter. Okay. Here Y1, it is in meter. Your Z1, that is your datum head, it is also in meter. So all the unit is in meter. So that total energy you are going to calculate, it will be in meter. Okay. Or the specific energy you are going to calculate, the unit of that specific energy, though we are termed it as energy, it is in meter. Your Z1, that is your datum head, it is also in meter. So all the unit is in meter. So that total energy you are going to calculate, it will be in meter. Okay. Or the specific energy you are going to calculate, the unit of that specific energy, though we are termed it as energy, we are getting in meter. Okay. Suppose 10 meter of water, the total energy of that particular section is 10 meter of water. Okay. So our aim is to differentiate between the open channel and pipe flow. Okay. So why I'm discussing this thing, this is very important, and you should know the difference between your specific energy and the total energy. Okay. And what is hydraulic gradient line? If you join the water level in first section and the water level in the second section by a straight line, that is your hydraulic gradient line. It's GL. Okay. See, when I am saying this is a kinetic head, what is the expression for kinetic energy? Any idea? I think you all know that kinetic energy is half mv square, right? It's a very familiar equation. Everyone knows that kinetic energy is half mv square. Okay. So that m is your mass. Okay. You know, weight is equal to mass into acceleration due to gravity. Okay. So weight is mass into acceleration due to gravity. So what will be the mass? Mass is equal to weight by gravity. Okay. So here in kinetic energy, in place of mass, we can write weight by acceleration due to gravity. And here we are considering not kinetic energy, it's kinetic energy head. That is kinetic energy divided by weight. So we have to divide this by weight. Okay. So mass we replace by W by G by this expression. So this weight will be cancelled out, and the remaining term will be V square by 2G. Okay. V square by 2G. And if you substitute here the velocity equation, meter per second, unit of velocity, and acceleration due to gravity, meter per second square, the ultimate unit you are going to get in meter. Okay. So don't confuse. This is a very common question in the interview. Okay, what is the unit of total energy? Is in meter. Because people think that it's total energy. It's an energy, so they used to say some joule and all. Okay. But the actual one is meter. Because all the terms, if you see that y is nothing but your depth of flow, we measure depth of flow in meter. Okay. That z value is also in meter. So whatever the energy you are going to get, you are going to get in meter. Okay. So don't confuse. So that's why for kinetic energy head, it's called v square by 2g. I think you people have studied about this one, Bernoulli's theorem. There also you used to write v square by 2g. Okay. So this is the process for, or this is the derivation from where it came v square by 2g. Okay. Okay. Say in pipe flow, see our whole subject is based on open channel flow. That's why that's a figure open channel we are discussed in details. Okay. The pipe flow you people have already studied in your third semester, so we are not going to discuss this pipe flow in details. Okay, as this is not relevant to our subject, but to differentiate between the two, we have discussed the primary thing or the basic things. So in pipe flow, our kinetic energy head is same as our open channel flow. But when we talk about potential energy head in pipe flow is P by W. W is your specific weight, or you can say unit weight. Okay. But in open channel, our potential energy is depth of flow Y1. Okay. So in pipe flow, we have P by W, that is your specific weight, or you can say rho into density multiplied by acceleration due to gravity or specific weight. Okay. So you can write also P by rho into G. Okay. It's up to you. Or you can write small w, that is specific weight. So in pipe flow, your potential energy head is P1 by specific weight or unit weight. Okay. Other all are same. But in open channel, your potential energy head is Y1. Okay. So here also, so we will move on to the next, and that is your differentiate between pi flow and open channel. So here you can see first one, the height of the total energy from the datum is Z plus P by W plus V square by 2G. Whereas for open channel, Z plus Y plus V square by 2G. The only difference is the potential energy head, the middle portion. For pi flow, it's P by W, that is specific weight, P by specific weight. And for open channel, it's a depth of flow. Okay. The second point, the liquid runs full, that is, in other words, you can say no surface, free surface. And open channel, we have free surface. That means the topmost portion is exposed to atmosphere. Okay. Then flow takes place under pressure. Here, open channel, it due to the gravity. Okay, in the flow direction. Say in pipe flow, our cross section is constant throughout the pipe. Whereas in open channel, if you consider a river, the width of the river, the depth of river, it's all changing. Okay, so it's not constant. So that's why the analysis of those things is very complicated. Okay, as compared to your pipe flow. So analysis of open channel is very complicated as compared to your pipe flow. So definitely hydraulic gradient line, it is as same, but that potential energy head P by W here, and for open channel it's Z plus Y. So that is the only difference. Surface tension force that we have already discussed, we consider in pipe flow, and where in open channel that surface tension is we mostly neglected. Here it's written only considered at a very low depth. When the depth of flow in the open channel is very low or very less, then we consider surface tension. Otherwise, we neglect that surface tension. Next topic is types of open channel. Okay. See, you people have already studied types of open channel flow. Okay. So that also we are going to discuss in the next topic. But here this is open channel. Don't confuse. One is open channel and one is open channel flow. Open channel is the channel where topmost portion is exposed to atmosphere. And open channel flow, the flowing through the open channel is called open channel flow. The flow flowing through the open channel is called open channel flow. So there are types of open channel. The first type is based on whether the channel is man-made. Means the whether the channel is artificial or natural. So definitely we have already discussed, we have natural channel and we have man-made or we can say artificial channel. Example of artificial channel is canals, irrigation canals, drains, etc. Okay. So now if you consider an man-made channel or artificial channel, that irrigation canal may be of, because those are man-made. Okay, so maybe of rectangular channel, maybe of trapezoidal, maybe of triangular, maybe of parabolic. So second classification is based on the shape of the channel. That we are constructing that irrigation canal of what shape? It may be rectangular, so that channel can be differentiated again by this shape of the channel. It may be rectangular, trapezoidal, triangular, or parabolic, or exponential, or circular. Then you have one option here, wide rectangular. Do you people have any idea about wide rectangular channel? Any idea about wide rectangular channel? If you people have idea, then we are not going to discuss. Hmm. You have any idea about wide rectangular channel?
No, sir.
Okay, okay.
No, sir.
See, Suppose this is your rectangular channel. Okay, is it visible, right? The drawings.
Yes, sir.
Okay, okay. Fine.
Yes, sir.
Suppose this is a rectangular channel and this is the level of water. Okay, this is the level of water. The width of the channel is 100 meter. Okay, and the depth of flow is 1 meter. Okay, so this is a rectangular channel where the width of the channel is 100 meter and depth of flow is 1 meter. Okay, now if you find out the weighted perimeter, what is the weighted perimeter equation? What will be the value for weighted perimeter? 1 plus 100, then again here is 1. Okay, so depth of flow will be here 1 meter, then there will be also 1 meter. So weighted perimeter means this 1 meter in addition with the width of the channel, then again depth of flow, that is 102 meter. That is your weighted perimeter. So see, the width of the channel is 100 meter and your weighted perimeter is 102 meter. So it's almost same. Okay, so that wide rectangular concept is when you have such situation, that is the weighted perimeter is almost equal to your width of the channel, those channel are called wide rectangular or wide parabolic. It depends on the shape. Okay, wide parabolic or wide trapezoidal. Okay, but condition should be weighted perimeter is almost equal to width of the channel. Okay, so this is your wide rectangular concept. So when someone you say that wide rectangular, then you understand that this weighted perimeter of that particular channel is almost equal to the width of the channel. That means your depth of flow is very less as compared to the width of the channel. You can see here your width is 100 meter, whereas your depth is just 1 meter. Okay, so that's why your weighted perimeter and your width of the channel is almost same. Okay, so this is your wide rectangular channel. Okay, where your weighted perimeter is almost equal to width of the channel. Okay, so these are the shape. It's showing here rectangular channel, trapezoidal, triangular. This is parabolic, and then you have circular, and this is wide rectangular. Okay, where the depth of flow is much less than your width of the channel. Then we have compound channel. So those things we are going to discuss in later classes. Okay, in details. That compound channel. So and this is, see, this is your natural channel. Why it is complex? Because we don't have defined shape. That's it. What we can say, it's a irregular shape. So that's why our open channel flow is much more complex than your pipe flow. Okay. So moving on to the next classification. See, there are open channel, types of open channel. First one is based on the channel is man-made or not. Okay. Second one is based on the shape of the channel. And the third one is the boundary characteristics. So boundary characteristics is two types. One is rigid boundary and one is mobile boundary. So mobile boundary is for natural channel where we have erosion and all. So this mobile boundary, it depends on online channels, or you can say it is also for rivers. Okay, so this thing based on boundary characteristics we are going to discuss in next chapter. Okay, in details. What is rigid boundary? What is mobile boundary? Okay, what is line canal? What is iron line canal? And then we are going to design also for line canal and for unlined canal in next chapter. Okay, in unit 2. So now we are going to just skip this thing, and we will discuss in details in the next chapter when we are going to design the line canal and unlined canal. So what is unlined canal and what is line canal? So just for your reference, always remember mobile boundary is for your rivers. Okay, and rigid boundary, if you fix the boundary of the channel, suppose you have constructed a irrigation canal. Okay, you excavate the artwork, then you fix this shape by providing some brick wall, or by providing some concrete. Okay, so those things are called line canal. That means you are fixing the boundary. Okay, and what is the advantage and disadvantage, those things are also we are going to consider discussed in the next class. Sorry, next unit. Okay, so and the fourth classification fourth classification is based on the cross section and slope, that is prismatic and non-prismatic. Say what is prismatic? Suppose you consider a pipe, you can see that cross section is throughout the pipe is constant. So those section is called prismatic. When your cross section is remain constant. Okay, and non-prismatic when it's not constant. Okay, like suppose you consider a river where we can see that our slope of the channel or the width of the river, okay, all are not fixed or not constant, it varying. Okay, so those are called your prismatic and non-prismatic channel. Suppose if you constructed a canal, irrigation canal, or okay, let's take an example of irrigation canal. You can see it may happen that your cross section of the canal is constant. Okay, so those canal we can consider as a prismatic open channel flow. Okay, but if you consider the natural channel, you cannot consider it's a prismatic channel. Okay, to simplify your calculation, you can consider prismatic, but practically it is impossible to consider as a prismatic channel, that river. Okay, because we all know the width of the river is varying, the slope is also varying, all the parameters we can measure all are varying with respect to space as well as time in your natural river system. Okay, so always remember our river system is a non-prismatic channel. Okay, but in some derivation, what people do, they consider it as a prismatic to simplify their calculation, and they did some calculations. Okay, so it doesn't mean that they consider it prismatic, it is a prismatic channel. Practically it is a non-prismatic channel. To simplify their calculations, some people consider as a prismatic channel. Okay, so here it ends your types of open channel. So next is types of open channel flow. So first classification is open channel, and second is types of open channel flow. I think those things you have already studied. Steady, unsteady. Do you want me to explain again about this steady flow, unsteady flow? Because I think you have studied in third semester. So you want me to discuss this steady flow and unsteady flow? And you can say bed of the channel. Okay, water is flowing here. Sorry, water is flowing. Okay? This is the level of water. This is the level of water. Okay. See, in this river, we consider two sections. Here one, okay, and okay. So this is a higher elevation than this section two. So the water will be flowing from higher elevation to the lower elevation. Definitely. Okay. So now come to the first point, steady flow. Okay. You come to the first section, you measure discharge. Okay. You measure velocity at first section. Okay. At first section, you measure discharge, you measure velocity, then you measure depth of flow. Okay. Understood? Then you wait for another 1 hour. Then you are measuring the same parameters in the same section. That is section 1. After 1 hour. After 1 hour. After 1 hour, again you measure discharge, velocity, depth of flow. If all the parameters are same, then we can say it's a steady flow. Understood? We are not moving to the second section, okay? In first section, we are going to measure discharge, velocity, and depth of flow. And then after some time, let it be as 1 hour. After 1 hour, again you are measuring at the same section and you are getting the same value of discharge, same value of velocity, and same value of depth of flow. Then that flow you can say is a steady flow. That means the flow is not changing with respect to time. Okay, it remains constant. Okay, so that is your steady flow. If those values are not same, then we can say it's a unsteady flow. Understood? Okay. 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 It's very simple. Okay. See, that's why you don't have to memorize those things. Okay. Steady flow. You can draw a diagram and see in first section if you measure discharge velocity and depth of flow, and after some time it may be 1 hour, 2 hours, or 1 day. Okay, that depends. Or after 15 minutes, it may be happen after 15 minutes. Again, you measure this discharge, velocity, and depth of flow at the same section. And if those two parameters or those parameters are same, then we can say the flow is steady flow. Or if they are not same, then we can say the flow is unsteady flow. Okay, so that's what is here written. The flow parameters such as discharge, velocity, and depth do not change with time. That means it kept constant with respect to time. Okay. Yes, so today actually this meeting is going to over very soon within 1 minute. Okay, so we will continue in the next class. Okay, and kindly give your attendance. Just you put your enrollment ID and your name. Name and an enrollment ID. Bamang, what's your enrollment ID? And Laisram. Okay, we will continue in the next class. Okay, thank you all.